thus far, we have studied angles and angle movement in the clockwise direction. So we've looked at things like, for example, this first problem here, Module 7, Investigation 9, number 1. If we go back to good old Stinky on the fan blade and he's rotating around, then we can look at this angle in standard position. Get my pen back out. Apparently I don't have it out. Oh, I'm still on eraser. So if this is standard position, right, here's my initial ray, and it looks like here is my terminal ray, right here. So what we have been looking at thus far is this angle here in the counterclockwise direction, and we've been calling that angle pi. What I want to talk about today is what happens when we move in the counterclockwise direction, like it's marked here, this guy here. What angle would this be called? Well, if we're looking at the angle of rotation, and this guy here was positive pi, then this one here should be negative pi, right? So this, I'm going to call the second angle beta. We'll call that negative pi. And I want you to think about, if it's not quite that clean cut, what do we do with it? How do we tell what the clockwise versus counterclockwise measurement is? So let's take a look at part B of this same problem. There's a lot on this slide, so I'm going to kind of zoom in and out a little bit. Okay, suppose this. The fan rotates 3/4 of a complete rotation in the clockwise direction. So here's the initial ray, and then the terminal ray, oops, that's pretty bad. The terminal ray would be up here, right? Terminal ray would be up here. So the question is, if it's a 3/4 turn in the negative direction, what measurement do we use to describe this angle of rotation? Well, since it's in the negative direction, it's going to be negative. And since it's a 3/4 turn, we know it's going to be 3/2 pi. So in this particular case, it would be negative 3/2 pi. On the other hand, though, if we were to look at that in the other direction, if we were to sweep it out counterclockwise instead of clockwise, what is that angle? So the angle of rotation there, because it's in the positive direction, it's going to be positive. And we know that that's a quarter rotation in the positive in order to end at the same place. We're really talking about, like, where is the terminal ray? The terminal ray is here for the negative angle. So how do we get to that same terminal ray from the positive? And so that's a quarter turn, or half pi. So think for just a moment, if that's the case, what could we do to start thinking about a formulaic way of getting from the positive angle to the negative angle and vice versa? So it says on part C, it says angles with the same terminal ray are called coterminal angles. So that's an important piece of information, coterminal angles, which means they end at the same place. They have the same terminal ray. It says assume that we're measuring from the 3 o'clock position, right? So that's just standard position. So part 1 says an angle measures alpha radians, where alpha is a negative number. And alpha, by the way, is a Greek letter that looks a lot like an A, but it's, when I draw it, it looks like a little fish. Pardon me for that, but it's going to happen. The angle is coterminal with an angle measuring 3/4 of pi radians. So let's just draw that out real quick. So we've got, give ourselves standard position here. Okay, we've got an initial array here. And then it says alpha is a negative number. Okay, the angle is coterminal with, or ends at the same place as, an angle that measures 3/4 pi rotations. So, or 3/4 pi radians. So 3/4 pi, we know, would go 3/4 of the way to a half rotation, because this is pi over here. Here's our 3/4 pi. Okay, 3/4 pi. And they're asking us, if this right here is alpha, what is alpha? So to get from this 3/4 pi to alpha, take a moment, pause, and think about what you might need to do that. It's clearly more than half a rotation, right? So it's pi and a bit more. Specifically, it's pi and another 1/4 pi more. So this is going to be 5/4 pi, but it's going to be negative because we're headed in the clockwise direction. Part 2 says, okay, suppose we have an angle measuring alpha radians where alpha is a negative number, so same kind of situation. The angle is coterminal with or ends at the same place as an angle measuring 7/6 pi radians. So 7/6 is more than 1, so that's going to take us over here into the third quadrant. Here is our 7/6 pi radians. What could be the value of A? So again, we're looking for what is the measure of this angle. Well, it's going to fall short of pi, and it's going to fall short of pi by 1/6. This is 1 and 1/6. 7/6 is 1 and 1/6. So we know it's going to fall short by 5. It's going to be 5/6 pi, but in the negative. And so the question is, can I define a function of f that outputs the negative measure of a coterminal angle with an angle measuring theta radian? So we want to figure out how to get alpha as a function of theta, where theta is our positive angle, right? It falls between 0 and 2 pi. So here's our positive angle, and here's our negative angle. I told you that my alpha was going to look like a fish. Sorry about that. So take a moment and see if you can figure that out. To get these values up above here, we took 2 pi and we subtracted off the given angle, only our response was going to end up being a negative. So we can use this as the formula, or we could clean that up a little bit and recognize that if we do theta minus 2 pi, that would also get us there, which makes a lot of sense when you think about it, because if we took either of the angles that are up here, switch colors, either of the angles that's up here, we've got this guy here. If we were to rotate backwards 2 pi, backwards 2 pi on either one of them, then we would arrive back at the same place, right? Because every time we make a 2 pi rotation, we end up right back where we started, as we know that a full rotation is 2 pi. So that works out. Okay. Now, when we're looking at that information, it's also interesting. Okay, so we know what coterminal angles are. Coterminal angles, if we have, for example, this guy right here, right? Let's put him, I don't know, let's put him here. Let's say that he is, let's call this 1 4/5 or 9/5 pi. I don't know why, I just chose something. It's positive 9/5 pi. So to find the coterminal angle, if I want a negative one, then I should be able to get alpha, I could do f of this 9/5 pi, and I could do 9/5 pi minus 2 pi, okay, which if I do it longhand, right, that's 9/5 pi minus 10/5 pi, right, because 2 would be 10/5, or negative 1/5 pi would be this angle right in here, right? This would be negative pi over 5 or negative 1/5 pi. Okay. The other thing that we should explore when we're talking about negative angles is what kind of effect does a negative angle have on forward and backward rotation from 0, right? So as we move forward, we know what the shape of sine looks like. We know what the shape of cosine looks like, right? As we move forward from 0, right? Cosine looks like this, right? Does that thing. We know moving forward from 0, sine does this thing. And what we want to explore in this particular thing is how is that related to the way that sine looks when it moves backwards, right? How is that related to the way that cosine looks when it goes backwards? So let's take some time to consider that. So what I want you to do is I want you to find these output values. We've got cosine of t is what we're looking for, and t is 0 and negative pi over 6 and negative pi over 4 and negative pi over 3, etc. And what I want you to do is I want you to find the output, the cosine of each of these angles, and then the cosine of the negative those, which would make them positive, right? So, for example, if we looked at the cosine of, let's see if I can shrink this guy down. Yeah, I can, cool. Let's see here. The cosine of negative pi over 6. Ugh, what are you doing? I don't even know what it's doing. Hold on. Weird calculator. Okay, so if I did the cosine of, oh, right. It's annoying. But anyway, you know what? Let's just use Desmos. That would be simpler. So if we did the cosine of negative pi over 6, we'd get this answer right here, this 0.866. So let's type that in up here. So this 0.866 is what we get here. Okay, if we did the cosine of 0, well, the cosine of 0, we know what that is. That's 1, right? That's weird. Oh, I know what happened here. Crazy times. There we go. Anyway, the cosine of 0 is 1. We know that. That's not a problem. Okay. Cosine of negative pi over 4. So if I go down here and I replace this with 4. Oops, I did not replace it with 4. Thought I did. Okay, I get 0.707. Okay, so that's what I'd like for you to do, to pause your video and consider what are these values as we move through here. I'm going to pause mine and do the same thing. Okay, so looking at what we got there, you can see that in the cosine function that all the outputs for the first column and all the outputs for the second column are identical. If they're not, you might want to double check your parentheses use in your calculator or whatever else. In sine, though, all of the values in the first column are replicated in the second column, but it's the negative of those, right? So those are opposite signs in the first and second columns here. So what's really happening, let's see here, let me give myself a text box out here. Maybe. There we go. What's really happening here is that we can see that the cosine of negative t is equal to the cosine of t. It doesn't really matter which one is which, right? It's an even function. Whoa, what just happened? I don't know what happened. Sorry. So we have an even function. On the other hand, we can see that the sine of negative t is not the same as the sine of positive t. In fact, we could write that this way. We could say that the sine of negative t is equivalent to the negative sine of t. So, because whatever came out here, was negated here. So the sine of t and the sine of negative t are negatives of each other, the outputs. And instead of calling that an even function, we call that an odd function. It's symmetrical about the origin. Let's look at the graphs real quick and just kind of convince ourselves that that's true. Let's take a look on Desmos. So if I graph y equals sine of x and y equals negative sine of x, do you see how they create this kind of completed loop here, that one is the reflection of the other, both over the y-axis and over the x-axis, which is why we call it an odd function. It's technically symmetrical about the origin. We could take this entire thing and we could flip it over. We could do a 180-degree rotation right there at the origin, and it would match up with itself. On the other hand, if we look at the cosine function, y equals the cosine of x, as opposed to y equals the cosine of negative x. Notice that they're the same thing. And I just realized that I wrote those really weirdly up there. Let's actually test what we thought we were testing. This was supposed to be y of sine x and y sine of negative x. But because those are the same, you can see how that's working out. So that's the same thing. I typed it out incorrectly, but it has the same meaning. But on the other hand, cosine of negative x and cosine of x, there is no change whatsoever. It is symmetric about the y-axis, but not about the x-axis. And so we call that an even function. All right, so that takes care of, and I'll type that in here. So that takes care of our talk of negative values for now. Although, hey, let's take a look at tangent too. Let's just double check and see which one of those we think tangent might be. Y equals the tangent of x versus y equals the tangent of negative x. So we can see that just like with the sine function, it's symmetric about the origin. So if we took the entire tangent function and we rotated it 180 degrees, or we rotated it pi actually, but if we made a half-turn rotation, we would see that this graph would match itself. This is also symmetric about the origin. So we can actually kind of add a little piece of information here. Let's give ourselves an extra little text box here that says that the tangent of x, the tangent of t in this case, of negative t, is equal to the negative tangent of t, just like the sine function. It's also an odd function, meaning it's symmetric about the origin. So that gives us some information here. Sine and tangent are both odd functions, and cosine is an even function. This particular thing is going to work into let's see if I can get this to open quickly, but this is going to work into the trig generalizations page that we have been working on, because we'll be able to see, what just happened? There it is. Let's go right here. So the trig generalizations page, we have this information towards the bottom of both of them that talks about well, that's very weird. Oh, okay. We'll leave that alone. He'll see it when you log in and take a look at that page, and we'll talk about it in class some too. But this has to do with the it relates to the row where we talk about f of negative x on that trig generalizations page. So take a moment and see if you can figure out how that would relate, and we'll talk about that more in class. Anyway, thank you for listening, and that takes us through some negative angle information.